Hello and welcome to part 2 of lesson number 8 in Unit 2B, Quadratic Functions, Forms, and Transformations in our grade 11 University College math class. This is converting from standard form to vertex form, also called completing the square. So in the first part of this lesson we talked about why we might want to transition from standard form to vertex form, because vertex form is better. It just gives us more information we can use to graph. And we talked a little bit about the thinking behind the procedure, where completing the square literally means we're going to take the ax squared and the bx from within standard form, create a perfect square trinomial by adding a new value, a new c. To keep the equation balanced, we're then going to subtract c at the same time. We're going to use the ax squared plus bx and the new c to factor down into a perfect square trinomial that's been factored, so a one binomial squared. And then we're going to take the new subtracted c and the constant provided in the question and simplify those to get the k component of our vertex. From there we have the a value already, so we know direction of opening, plot pattern, and from this now completing the square conversion, we now have the vertex. So it's perfect. So there it is. There's some instructions if you need to reference them. We're just going to jump right in with another example. So here we have y equals x squared minus 8x plus 2. Okay, so we're going to start by recognizing that this is in standard form because there are no brackets. If we want to get to vertex form, we need to create a perfect square trinomial. So we're going to start by laying out the bare bones for that. So x squared minus 8x plus a new value, subtract a new value, and there's our plus 2. And recall that our the reason we're adding and subtracting, the reason that we're doing the adding is so that we can make a nice perfect square trinomial here. The reason that we're doing a subtraction of that exact same value is to keep this equation balanced. So let's just jump right in. How do we figure out what the value is that goes there? Well, as you remember, the relationship between a perfect square trinomial and its component pieces, the c value specifically, is that we're going to take half of our b value, which is minus 8, and we are going to square it. So half of negative 8 is negative 4, which we're going to square to give us 16. So we have a 16 going in here, a 16 going in here, and again, I'm just going to keep saying it. The first 16 was added to create the perfect square for us to factor. The second 16 was subtracted in order to keep the equation balanced. So now we have a couple things to do. We are going to factor this guy here, and we are going to simplify this guy here. So if we are going to factor this first trinomial, we are looking for something that's going to multiply to plus 16 and add to negative 8. And as I said before, you can find that value right here. Once you've taken b and cut it in half or divided it by 2, you end up with negative 4. Negative 4, as you know, if we multiply negative 4 times negative 4, that gives us plus 16. And when we add negative 4 and negative 4, we get negative 8. So we are going to have x minus 4 here in the brackets. The last two values we are just going to simplify. Negative 16 plus 2 gives us negative 14. So here we've moved to vertex form. Our vertex is going to be 4, negative 14. Our plot pattern is going to be 1, 4, 9, since our a value is going to be 1 and our parabola opens up. So there you go. That is another example of completing the square. Unfortunately, this is kind of the easiest one. We're going to actually look at another example that introduces a harder concept. Now the harder concept is this. If we have a quadratic that has a coefficient out front, we can't create a perfect square from that because when we're building a perfect square trinomial, the ones we're going to be building anyway, they don't have coefficients out in front of the x squared. So what we need to do is get rid of that 2 in some way while still retaining the basic form of this standard form quadratic. The method for doing that is to common factor. So we have y equals, now what I'm going to common factor out, I'm going to write it right here, is common factor just the 2, common factor 2 from, I'm going to write this in a more general way, ax squared and bx. So basically the first two terms I'm going to common factor 2 from. Again, I don't want to common factor everything I can because then I would factor out a 2x, but then I wouldn't have a quadratic anymore in a form that I could create into a perfect square. I just want to get rid of the 2. So when I common factor out the 2, I'm left with x squared minus 2x, close the bracket, and there's our plus 5. Now people ask all the time, is it okay to common factor the 2 out of the 5? Of course it is. You're just sometimes, anyway, maybe even most times, you're going to be creating a situation where now you have to deal with fractions, and that's kind of just a pain, and it's not necessary. So I usually recommend just common factor out the coefficient from the ax squared and the bx term, and don't worry about the c. It's just going to kind of take care of itself. So from here, we've now got, inside the brackets, the beginnings of a perfect square trinomial, which we are now going to lay out. Ax squared minus 2x plus something minus something, and there's our plus 5. I'm just going to keep saying it. We're putting this value in, this plus something, to create this perfect square. We are then going on to subtract that same value because that's going to keep our equation balanced. So let's get whatever that value happens to be. That value is going to be, let's find out. So I'm going to take my b value, which is -2. I'm going to divide it by 2 and square it. So -2 divided by 2 is -1, which squared gives us 1. So I'll be putting a 1 in here and a 1 in here. Now we're left with a beautiful trinomial, and this piece here, which we need to simplify. Now, there's one other thing, and I'm going to do a rewrite step here just so I have a little more room to write a few notes on it for you. At this point, we've got y equals 2 x squared minus 2x plus 1 minus 1 close bracket plus 5. You'll notice that the coefficient we put into balance, this guy right here, you'll notice it's actually trapped inside the brackets because we completed the square in a place where we had already common factored 2 out of it. So in order for it to be on the same sort of playing field as the plus 5, we need to break it out of the brackets. And the way that we remove terms from brackets is to expand them out. So what we're actually going to do is, let's do it in hot pink. We are actually going to multiply the term that we want to free from the bracket by the coefficient we common factored out front. So that's going to actually be 2 times -1, which means we're going to have a -2 here. So now, by doing this, what we've done, whoops, it's not the right blue. What we've done is we've created a y equals 2x squared minus 2x plus 1 and a plus 5 and a -2. So that procedure, by multiplying the -1, the value we added to balance, by multiplying that by the coefficient out front, we've essentially freed it from the brackets, and now we can simplify it with plus 5. So last couple steps here, I'm going to factor the trinomial we built, and we are going to simplify these two values. So let's do it. We have y equals 2. Now we're looking for the thing that multiplies to plus 1 and adds to -2. If we go back, it's right here inside the brackets. So that will be x minus 1 all squared, and then we simplify plus 5 and -2 to a plus 3. Now, I also want to point out that this 2 is going to travel the whole way down this equation with us. We can't just abandon it. After we common factored it out, it shows up in every single step, because guess what? That's the a value. That tells you something about this quadratic. So if we are at our final point here, what is our vertex going to be? The opposite of how it appears for our x values, that'll be 1 and 3. Our plot pattern will be 1, 4, 9, amplified by our a value, which is 2. So from our vertex, we go out 1, up 2, out 2, up 8, out 3, up 18, and we know that the direction of opening is up since our a value is positive. All the information that we need now to graph. So you have two really good examples on this page of how to complete the square. I highly encourage you when you're working through the homework to reference these examples and listen to them again if you need to. It is a complex concept. There's a lot of steps involved. Well, maybe not a lot of steps, but there's steps involved with particular purposes. And I've tried my best to explain them in such a way that you understand why you're doing things rather than just what you're supposed to do. Hopefully it helps. Again, rewatch it if you need to. We just have another couple examples here. Now that's going to take a little bit of time. So why don't we just tackle that in part 3, and we'll see how you can kind of cheat the completing the square process by using formulas to determine what your vertex form version of the quadratic from standard form will be. So we'll see you in part 3.